Our Tennessee State Standard today is to solve linear equations with rational number coefficients, including equations whose solutions require expanding expressions using the distributive property and collecting like terms. Your lesson objective today that you need to pause the video and write down: I am learning to solve one-step multiplication and division equations using the division and multiplication properties of equality. Now, we talked a little bit about algebra tiles, so we're going to 2x. That says 2 times x. That means here's 1x and here's 2x. 2x equals positive 8. So 1, 2, 3, 4, 5, 6, 7, 8. Well, I don't need to know what 2x is equal. I need to know what 1x equals, so I can separate or divide these x's into two groups, which means I need to separate on the right side my 1. So 1 there and 1 there, and 1 down here and 1 there, and 1 down here and 1 there, 1 down here and 1 there. So if 2x equals 8, then 1x equals 4. And we can draw these also. If we have 3x, well, there's 1x, there's 2x. Ooh, that was bad, wasn't it? And there's 3x, 3 positive x's, so equals 9. So here's 1, that's 3, 4, 5, 6, 7, 8, 9. So if 3x equals 9, then 1x equals 3. 5x, we would divide into 5 groups, and each group would have, if 5x equals 10, then 5 times 2 equals 10. If 4x equals negative 12, well, let's do this. Here's an x, here's an x, here's an x, and here's an x, all positive, but now we've got negative 12. So there's a negative, there's a negative, there's a negative, so there's negative 4. Oh my goodness, I did that wrong. I put plus signs. So negative 4, negative 5, negative 6, negative 7, not positive, negative 7. My goodness. You're going to have to keep me honest here. That's a negative. So this would be negative 8, negative 9. Oh my goodness. I'm so used to doing those positives. Negative 9, negative 10, negative 11, negative 12. So if 4x equals negative 12, 1x equals negative 3. So I want you to think about this question and be ready to discuss it tomorrow. Explain how to solve the following equation without using algebra tiles. And the equation is 6x equals 42. All right, so if we want to undo multiplication to get our variable by itself, we want to use division, which is the inverse operation. So if we have 10h, 10 times h equals 60. If we divide by 10, 10 divided by 10 will give us 1h. 60 divided by 10 gives us 6. So h equals 6. And to check it, we can put this back into the original equation. 10 times h, which is 6, equals 60. So we know that is correct. Okay. The division property of equality says if you divide each side of an equation by the same non-zero number, the two sides remain equal. Why do you think they say non-zero number. I want you to think about that for tomorrow, and we will talk about why they specify non-zero numbers. All right, so if we start out with 12 equals 12, and we divide both sides by 4, 12 divided by 4 equals 12 divided by 4, 3 equals 3. Our equation stays balanced. So if we have a variable in the mix, 5 times x equals negative 60, we can divide by 5, which gives us 5 divided by 5 gives us 1x. And when we divide negative 60 by 5, we get negative 12. Now, if we want to check that, 5 times x, which is negative 12, equals negative 60. So that is correct. All right, what do we divide by here? Divide by the coefficient of 8 on both sides. So x equals 72 divided by 8 is 9. And then you can say 8 times 9, which is x, equals 72. We're going to divide here by the coefficient, negative 6. So negative 12 divided by negative 6 is 2. This gives us 1k. So k equals 2. Negative 6 times 2 equals negative 12. And divide by the coefficient again. This gives us 1n, and 28 divided by negative 4 is negative 7. Negative 4 times negative 7 equals positive 28. In a real-world example, an adult lizard is about 5 times as long as a hatchling. If an adult lizard is 11 centimeters long, about how long is a hatchling? Well, an adult lizard, let G represent the length of the hatchling. So, 5 times as long as a hatchling. So 5 times G for hatchling equals an adult lizard, which is 11. So if we have the equation 5 times the length of a hatchling equals the length of a lizard, 11, we're going to divide by 5, and G equals 5 goes into 11 2 times with 1 left over, 2 1/5, which is also equal to 2.2 centimeters, which is the length of the hatchling. The multiplication property of equality says if you multiply each side of an equation by the same number, the two sides remain equal. We start with 5 equals 5, balanced equation. We multiply both sides by negative 4, which gives us negative 20 equals negative 20. X over 2, or x divided by 2 equals 8. We want to get rid of this denominator, so if we multiply by 2, which would be over 1, that cancels those out and gives us x equals 8 times 2 is 16. So to solve a division equation, we're going to multiply by the denominator. A divided by negative 3 equals negative 7. We're going to multiply by the denominator of negative 3, which cancels out, leaves us with A. Negative 7 times negative 3 is 21. And if we want to check that, we put this back in for A. 21 divided by negative 3 equals negative 7. So we know our answer is correct. More examples. So we're going to multiply by negative 4. Multiply by negative 4. This cancels out. Leaves us with y equals negative 8 times negative 4 is positive 32. Plug that back in. 32 divided by negative 4 equals negative 8. Multiply by the denominator, so times negative 2 times negative 2 cancels out, leaves us with b equals negative 60. And we check that by saying negative 60 divided by negative 2 equals positive 30. Multiply by the denominator, times 5 times 5. These cancel out, gives us 1m equals negative 9 times 5 is negative 45. We're going to plug that back in for m. So negative 45 divided by 5 equals negative 9. Now let's look at a real world example. When the marbles were divided among 3 players, each player received 16 marbles. How many marbles were there? Well, we don't know. Let m represent the number of marbles. We have marbles divided among 3 players, and each player received 16 marbles. So we multiply by the denominator, which cancels out the denominator, leaves us with m equals 3 times 6 is 18, 3 times 1 is 3, plus 1 is 4. And then you can plug that back in. 48 divided by 3 equals 16. And last question, the recorded amount of precipitation is 1/10 of the amount of fallen snow. If Redfield received 3.6 inches of precipitation in 1 week, how many inches of snow fell? So recorded amount of precipitation, let's say P equals 1/10. So 1/10, we're going to do it like that, of times the recorded amount of precipitation is 1/10 of the amount of fallen snow. Oh no. Let's go back. Because I'm confusing myself. Let's try this again. See if I can make mistakes. So Redfield received 3.6 inches. Recorded amount of precipitation is 3.6 inches. That's what they recorded. That is equal to 1/10 of the fallen snow. So we're just going to put 1/10 F. Well, let's rewrite this. 1/10 times F is the same thing as F over 10. Now we can go back to multiplying by the denominator. So that leaves us with F equals, and when we multiply by 10, we move the decimal to the right, making the number bigger. So the snowfall would have been, had the precipitation been all snow, the snowfall would have been 36 inches. So think about that. When it calls for snowfall this winter and it turns to rain, think about how much rain we got, and you could multiply that by 10 to find out how much snow we would have gotten if it was cold enough. All right, that's the end of the lesson, and I will see you tomorrow.